This is Mrs. Grizafi. Welcome, Geometry Honors students. And we are on 10.00B today. So I divided 10.00, I think I mentioned last time, into two parts, just because they're really important and we see them a lot next year in Algebra 2. So last class we talked about converting between radians and degrees. Hopefully that made sense using that proportion, and you'll start to see faster ways of doing that as well, multiplying by pi over 180, things like that. Today we're going to talk about sectors, which is just kind of like a piece of the pie. So if you have a circle and you take one piece of the pie, let's say like this piece right here, that's called a sector. And we're going to talk about how to find the arc length. The arc length is the distance on the circumference that piece of pie takes up. So it's kind of like the crust of the pie. And the area of the sector is the amount of area that the pie takes up. So we have two formulas to do these with. And there's also ways to do it using a proportion as well. I'm going to use the formulas with you guys to practice converting between radians and degrees. And also, these are the formulas that we often use in Algebra 2. And they sometimes make things just a little bit faster depending on the information that you're given. So S stands for arc length, and R stands for your radius, theta stands for your central angle. So what a central angle is it's an angle that has a vertex at the center. So right here, if this is the center of our circle, this is an angle whose vertex is at the center. So that would be your theta. S is the distance along the circumference again, that's your arc length. And A we use for area of a sector. So S equals R theta, radius times theta, your central angle. Area of a sector is 1/2 r squared theta, so your radius squared times theta. The big thing here that's most important, to use these formulas, theta must be in radians. So both of these thetas right here have to be in radians, not degrees. So number one says find the arc length and the area of the sector. If the radius is 3 feet and theta is pi over 18 radians. So we're good here because we're given in radians. Given radians, yay. So we want to find the exact value and also round to the nearest hundredth. So let's start with our arc length. Arc length, our formula is S equals R theta. So these formulas are not given to you on a reference sheet though, so they are formulas that you would have to memorize. So arc length is my radius, which is 3, times theta, which is pi over 18. It's already in radians. So I'm going to put 3 over 1 to make it into a fraction. And then I can cross reduce. 3 goes into 18 6 times. So my answer is pi over 6, and that would be feet. So pi over 6 is my exact answer because it's not rounded. It's in terms of pi. And that would be exact. If I wanted an approximate, then I'm going to type in pi divided by 6 into my calculator. So use your pi key divided by 6, and that'll give us our approximate value, which would be 0.52359877756. And this says to round to the nearest hundredth, so it would be 0.52 feet. And so that would be our approximate value. This right here is also an approximate value because it is pi goes on forever and ever. So this decimal also goes on forever and ever once we put pi into it. So this is an approximation. We want our approximation to the nearest hundredth though. So it'd be 0.52 feet. Now let's talk about the area of the sector. So we're going to use our formula, which is 1/2 r squared theta. So we're going to put in our radius, which is 3 squared theta is pi over 18. I'm just going to kind of simplify here. So 3 squared is 9. Since we already have fractions, I'm going to write everything as a fraction. And then again, I can cross reduce. So I know 9 goes into 18 twice. So I'm left with pi over 4. So my area is going to be pi over 4, and that's going to be feet squared because we're area. Again, this is exact because it's in terms of pi. Approximation, we're going to type in our calculator pi and use the pi key. Divide it by 4. Gives us 0.785398164. Round that to the nearest hundredth, so 0.79 feet squared would be our final answer. And both of these, again, are approximations. Exact means it has to be in terms of pi or simplest radical form. And that's it. Now, number 2 will get a little bit harder because this one we're given r equals 12 inches. So our radius is 12 inches and theta is equal to 90 degrees. So this is really acting up on me today. I'm just going to give it a minute. So when theta is 90 degrees, in order to use these formulas, theta has to be in radians. So what I would like you to do first is focus on getting that theta into radians. So we're going to take 90 degrees and convert that into radians, because our formulas won't work unless it's in radians, and you have to do it at the beginning. You can't convert at the end. I want you to convert theta into radians and then sub it into your formula. So first, convert. And next year, you guys are going to talk a lot about this. You're probably going to have this one memorized. So we're going to use our conversion proportion pi over 180 equals radians. I'll call that x over degrees, which is 90. Remember, degrees always goes across from 180, radians across from pi. Get 90 times pi when we cross multiply equals 180 times x, divide by 180. And again, you maybe have learned the quick trick already that you're just dividing by 180, multiplying by pi. Reduce 90 over 180 in your calculator. That's going to give you 1/2. Then bring along your pi. Remember, don't type the pi key in your calculator when you're reducing 90 over 180. So x is pi over 2. So x is going to be our theta. Okay, so that's step number 1. Now, number 2, we want to find the arc length. Now, notice also it does not say to round. So if it doesn't say to round, what do? That's right, we don't round. So don't. You want to leave it exact, which means in terms of pi. So our arc length formula, S equals r theta. We know the radius is 12, and now we know theta is pi over 2. Now also remember, you do not need the arc length in order to find the area of the sector. I'm asking you to find both for these, but you only need to find one or the other. You don't need your answer from arc length to find the area. Put this over 1, and we get 6 pi, and this one is in inches for our answer. So that would be our exact value. So now the third thing we're going to do is find the area of the sector. Again, you didn't need to do step 2 in order to do the area. You just needed to have done step 1. So area is 1/2 r squared theta. Substitute in, so my radius is still 12 inches squared, and theta is still pi over 2. You do not put in 6 pi in for theta. That's your arc length. You're putting in theta is pi over 2. Okay, so now we can reduce here. We get 144 for our 12 squared, and then we can cross reduce, or you could multiply straight across the top to get 144 pi divided by 4. However you do it, you should end up with 36, 144 divided by 4, and then your pi. And this is area, so it's going to be inches squared, and that's your exact area. Okay, number 3. A little bit different. If the arc length is 6 centimeters and the central angle is 1.5 radians, find the radius. So we're given the arc length, so let's start with our formula for arc length, which is S equals r theta. So I know S represents the arc length, so that's 6. My radius, I don't know, that's what I'm looking for. And theta is my central angle. So that's going to be 1.5 radians. So now I just need to solve for r. So I'm going to divide both sides by 1.5. And my radius is going to be 4, and we're in centimeters, so 4 centimeters. And that's it. So just a different way of asking the problem, finding a different piece. Number 4. If the arc length of a sector is 30 centimeters and the radius is 10, find the measure of the central angle in radians and degrees. So first, again, we're given the arc length is 30, so let's start with our arc length formula. We're going to sub in 30 for the arc length. We know the radius is 10. This time we do not know theta. We're asked to find it. So we're just going to divide both sides by 10, and we get theta equals 3. But that, because the formula only works in radians, you get out radians as well. So theta is 3 radians. So we've done that. Now I want you to also find the answer in degrees. So you first have to always find it in radians, then convert to degrees. So you're going to convert 3 radians to degrees. Now, normally if we convert from radians to degrees, if it has a pi in it, we can use that quick trick and sub in 180 in for pi. But since it doesn't, we're going to use our proportion again. So we're looking for the degrees this time. So I'm going to put 3 in for the radians and x in for my degrees. And then I'm going to cross multiply. So I get pi times x equals 540. Divide both sides by pi. And x is 540 over pi, and that's degrees. So if it asks for degrees, like we did here, just convert. Now, it didn't say to round, so that would be my final answer in degrees. If it asked me to round to the nearest tenth or hundredth or thousandth, then you would type in 540 divided by the pi key in your calculator, write out the full decimal, and then round to whatever it says to. Okay, number 5. If the arc length is 8 meters and the central angle is 60 degrees, find the area of the sector. Leave your answer in terms of pi. So because it's in terms of pi, this one gets a little complicated because I gave you the arc length and you need to find the area of the sector. So in this case, you do need to have one in order to do the other. Why do I need to know the arc length in order to find the area of a sector? Well, let's see. Our formula for the area of a sector is 1/2 r squared theta. So in order to find the area, I need to know the radius, and I need to know the central angle in radians. I know the central angle is 60. Well, easy enough, I can convert that to radians. I need the radius as well to find the area. I'm not given the radius. So in order to find the area, we need the radius. So how do we find the radius? Well, we were given the arc length. So let's see if that can help us because we haven't used that yet. So arc length is s equals r theta. We know the arc length is 8. We know the central angle is 60, so we need to convert 60 degrees to radians. So we'll do pi over 180 equals x over 60, cross multiply, we get 60 pi equals 180 over 180 times x, divide by 180, put 60 over 180 in your calculator, or reduce 6 over 18, and we get pi over 3. So that's my theta. Okay, so now I'm going to use that to find my radius. Remember, for all these formulas, you have to have theta in radians. So to get r by itself, because our final answer has to be in terms of pi, so we don't want any decimals here. So I'm going to multiply this side by 3 over pi by my reciprocal. Instead of dividing by pi over 3, it's always best when it's a fraction to multiply by the reciprocal. And I get 3 times 8, which is 24 over pi, is my radius. Okay, so now we've got the radius and we have theta, these two right here. So we want to go back to our area formula now, and we're going to put this in for your r and this in for your theta. So I've got area equals 1/2 times 24 over pi squared times my theta, which is pi over 3. So still kind of a complicated problem here, just in terms of the arithmetic. So we've got our 24 squared, it gives us 576 over pi squared. We have to square both of them to get rid of this squared out here, times pi over 3. Now let's see what we can cross reduce. I've got pi up here and a pi squared down here, so I still have 1 pi left in the denominator. And then I've got 576 over 6 pi, so let's do 576 divided by 6, which gives us 96. And that's going to be on the top because 576 is bigger, and the pi will stay on the bottom, and that'll be our area, so meters squared, in terms of pi as an exact value. And if you wanted an approximation, again, you could type in 96 divided by pi key into your calculator. But the big thing here is to make sure you put the radius as 24 pi in for that radius, that whole thing, and then square it. All right, hopefully that makes sense and helps you. That's it for our 10.00B notes. So next time we'll move on from these. And if you have any questions, please let me know. I hope you guys are all staying healthy and doing well, and I miss you guys, and I hope to see you soon. Pi out.